the simplest circuit I could make for a robot, and I'll show this one too. It's just a relay board with a little wireless receiver on it, and I got another wireless transmitter inside here. So this Raspberry Pi, when this computer comes around, I'm going to have it talk to this robot and send this robot off. So they can tag with the guidance little text editing frames. And this one starts a program that's actually connected to the Raspberry Pi, so I can get a graphical session. And actually get as you can see, Python is installed on here. It comes stock issued, already loaded on it. Tons of libraries available to work with.
So the screen we're seeing on the TV set is actually that small little $35 computer.
Right. I had a TV transmitter in my house working really well, transmitting from the robot to the TV. But it got really noisy in here, it wasn't working quite right. So that's what I what I tried to do was get it to find these targets and aim for it, have the robot guide for it. This computer vision library lets you separate out colors. It's actually I separate out blue, red, and green by using yellow instead. Different colors. And then the C program runs through and looks for yellow next to green pixels with blue on top. And anywhere it sees it, it averages out all the points and draws a line down it, saying the robot's going to go left or right, trying to aim for this target. You notice I've got 3 targets set up here. They're different color patterns. So if I turn the robot right now to go to this pattern, it won't see it. It won't guide itself until the program tells it to switch to that code. So now when we start it up, everything should just kind of go. Takes a picture, stops for a minute to I'm going to disconnect the camera when it runs. I mean the TV. Status messages coming up on the screen. What it's trying to do is trying to move forward. Keep aiming for that target, it'll center it up. Now it's got 2 cameras, so that's using stereo vision. At a certain point, the 2 cameras are going to look at an angle and it knows it's a certain distance from the target. So now it knows, okay, it's a certain distance. These are the teacher's desk, green, blue, yellow. That's what it said, so it's going to come over here now. The idea is to help the handicap right now with the robo contest and the Trinity Robot Contest. I got this going from my house out to the kitchen and back, following 10 targets around the house. So it can go back and forth. And there's people with crutches simply can't carry stuff from the room. And all they want to do is put something on the robot and carry it to the other room. They can go in the kitchen and repair it, walk into the other room. I had that problem when I was on crutches, so I know what they're going through. Later it should be even doing more things and more tasks for the handicap. Hoping to help some blind people with board education services. Blind for a while and got a lot of ideas. It's not that far off. This $35 computer is opening up a whole new realm. Portability of robotics. And all the software becomes available because it runs Linux. So suddenly, okay, now there's one more target over here on the first row of the desk. It's in the first desk row. And I'm almost, just bear with me another 2 minutes, we're going to see the whole demo. I'm working on a really cool thing now I'm trying to do is, you don't want to have these targets lying all around the house. It's almost embarrassing here. I've had a day right now trying to see what these 10 colored targets are all over the house. But now I've got a target mounted on another robot here. It says it's searching for a remote robot. It scans back and forth because it doesn't know where it is. And it'll twist back and forth, just for the sake of the demo, I'm just going to speed it up a little bit. Searching for remote robot. It's yellow, green, and blue. Found it. Now, this is where we talk about interpreters and compilers being a problem. I ran this 1,000-line program, and then I tried to talk on the radio waves to the small robot, and it went so slow that the robot would lose control because there's no brain in the subcomputer. It just turns it on and turns it off. So I actually subbed it in a smaller program, called it from a sub-scalar program, and ran this control program. It's got its own video control, its own imaging. Very difficult to take a robot shimmy to the left. This is where I started using modules and functions. The first browser line program was spaghetti code, a nightmare. I couldn't program this thing in spaghetti code, it's too difficult. But in the nice modular program, I could say shimmy left, the module shimmy right is when it says forward and is when it says align. And the combination of that is what actually makes the robot go forward. Now again, the eyes, rather than trying to look for how close together it is, they're going to look how far away it is. At a certain point, when it gets there, just finish the distance. Now then this robot, in the ideal speeding, will go up and look to that robot. Because it's set it to a number. It's much easier for this robot to stay in a fixed position, look only in one place, and send that robot out, rather than trying to move and figure out its whole environment, to decide where to move, and have to reanalyze the whole environment. Sit in one place, move the robot to a known spot out there, then go to that spot and send the robot out again. And that's how I'm trying to have tablet robots do really simple guidance through a house. And that's it. If this one comes up to that, that's the part I'm working on now. So that's my Python project obsession for right now. Thanks.